and I'm going to admit. So good afternoon, everybody. Thank you very much for attending and for the speakers for agreeing to speak today. We've got 3 fantastic speakers, actually from a range of different backgrounds. As you can see by the flyer, we've got representatives from the sort of drone developers and manufacturers, Motion Robotics, then people doing regular healthcare operations, which is David from the African Drone Forum, and we've also got Veronica, who's going to tell us a little bit something about the testing facilities at Cranfield. What I'm going to say to everybody is please put your questions into the chat and we'll try and get those to the speakers. If we have a lot of questions, then I'll go for which question got the majority of the thumbs up. But please put your questions in the chat as we're going along. So to the speakers, what I would advise you to do is not look at the chat while you're speaking, because that'll put you off a little bit, but that way we can capture some sort of nice points. So David, I think the floor is yours. So are you okay grabbing the screen? So I'm going to relinquish the screen now. And if you hit the button that says share with the arrow going up, I think we're all masters now.
Paul, I think it's Dennis actually first up. I'm
sorry, Dennis.
When I click the button going up, it goes close share tray, but it doesn't show me the share tray, does it?
Oh, okay.
Yes, it does. Okay.
Yes, it does.
Window. I'm hoping that the presentation works in normal presentation mode.
Yep,
you know what I mean?
Yeah.
In which
Dennis,
case,
that's looking fantastic. Thank you,
if
David, for correcting me there.
Do you end up seeing anything other than my screen?
Well, we can. There you go. That's brilliant. OSPREH, optimizing speed, productivity, resilience, and efficiency in healthcare. That's your presentation.
Yeah. Okay. Fantastic. So I'll kick off. It's 15:04. I've got up till 15:24. In theory. So OSPREH stands for Optimizing Speed, Productivity, Resilience and Efficiency in Healthcare. It was a 1-year Innovate UK project, which has recently ended the end of March, January, March. And it was between 2 companies, AVIATE, who I think a lot of you know about, and Motion Robotics, perhaps less you know about. During the project, we made a coffee cup, and this is the graphics we used. In fact, I think Paul, I gave you one. I gave you a coffee cup. I don't know if you still got it. And this is AVIATE's logo. This is our logo, and OSPREH was the logo for the project. And as you can see here, we've got little drones and parcels, and it's really much looking at artificial intelligence-based drone ports for pathology transport was the emphasis, and it was in the robotics AI call, looking at resilience in healthcare. What I'd like to do is to give you a little bit of an update of the results we had during the project. But before I do that, I'd like to put it into the context of how I see drone delivery and robotics being merged together, both in today's situation, from what I can see. I don't have eyes everywhere. I'm sure you may know of other people doing wonderful things. So what I'm going to present is only what I've seen in the past months and years. So today's situation, and then our results will hopefully show towards tomorrow's situation. So where are we on drone delivery? This is a Skyports drone, and we know that they're operating in the medical delivery space. We know that they're looking at fairly long range deliveries, so up in Scotland. Their payload, I believe, is not amazingly high, but it's very important being within the medical space. And we know that they've had MHRA issues in terms of everybody operating in the space, making sure that whatever they deliver is approved by medical, clinical health people and so on. I'm not sure about the drone's suitability to the objective of drone delivery when you look at it from the point of view of high volume deliveries, mainly because of the fuselage design even if it has changed since this photo and since I ever spoke to them long ago. I think all people working in the space using vertical takeoff but winged VTOLs are subject to fuselage design and aerodynamics. Another similar drone delivery system that's working is the Manor operating in the home delivery space. I don't think they're operating at long range, and I think they're mainly operating in areas in Ireland that have geographical disadvantage for delivery by road. I think their payloads are fairly light, consisting of mainly shopping items, coffee, snacks, and so on. As you can see on the left, there is this tells you how they actually do it. I think they by winching and delivering at height, they solve one of the problems, which is whether there are dogs and children and whatnot in the garden. But on the other hand, there is still a problem with lowering things onto the ground. So the question is, should you really be delivering by drone to the ground? If you look at the bottom right-hand side on their website, it shows that if you are a store and you want to work with them, they will send somebody to your shop. They'll collect the goods, take them back to their place, load them onto the drones, and take off and deliver it. Is that really cost effective? Is there a societal benefit to delivering coffee by drone? Alphabet Wing in a very similar situation in terms of the type of craft, type of delivery, and the type of fairly simplistic items for delivery. So our good friends Avian, operating in the NHS space, they're looking at speed as being one of the main factors that they can bring to deliveries in the NHS. They're already demonstrating their range from Queen Alexandra in Portsmouth to the St. Mary's and Isle of Wight, reasonably large payloads and increasing, looking at means to increase ease of loading and drop-off. Not sure that they are focusing on volume, but they are a serious healthcare customer, so they're working in a space that's very credible. And I do believe that Avian and Motion Robotics have the same, future vision of how more efficient and effective drone delivery has to be. So one of the most possibly successful in drone delivery right now is Matonet, looking at, again, medical space with a very high international presence. I don't think they're looking at very long range. The drones are fairly small. Payload is intentionally small, small blood samples and so on. And they're concentrating with their robotic systems, focusing on safety and ease of takeoff and drop-off, which is good. I don't think they're concentrating on high volume, but they are looking at stuff related to societal benefit, and they are serious users of the technology. So that just gives you my impression of a little bit of an overview of what's happening in the industry. And as I say, there may be a heck of a lot more going on. But I thought, what do we see in terms of automation and robotics? One of the things is more and more people are talking about winched deliveries. Why? Because it's fast and no need to land. But this only partially avoids the safety issue, because you still don't want to drop a parcel even by winch onto a dog or something. A lot of the winch systems rely purely on a hook, and you see the parcel actually swinging around as the drone flies, which is rather bad, I think. And even the basic winched approach over 30 meters, you're going to get very, very a lot of pendulosity in even the slightest of winds. Human loading is almost always used in this case, and therefore we wonder about the cost, safety, and the training. And automated loading and unloading, no, we don't see this at all. In terms of automation, automated, well, as far as I've seen, there are only a few instances which we'll look at later. And in terms of drone garaging, where we're going to put the drones at night, very early days. Looking at the winch, these are examples of winch systems. This one by Zing is it's almost a toy application. The Daiwa winch is much more professional. It's specifically designed to work with the Pixhawk, which is very common flight controller. Motion Now, just as an example of another, it's very expensive, but it does apply to a lot of different drone use cases, like water sampling, package delivery, and so on. But one of the very strong contenders in the winch is Wingcopter, and here is one of their 3-parcel triple drop delivery systems, which they very happy about. And I think reasonably high payloads, and but again, you can see how the system works. It still can swing around as an underslung load. If we look at human loading and unloading, well, why should we be worried about automation? One is human labor costs. Obviously, if we're loading purely by humans or unloading, we have to have someone there all the time, or many people. Even Matternet is still showing some of its products using human loading, although some is by automated loading. Wing, Canada Post, these top companies are still using, or at least they are demonstrating their services with human loading. And my question really is, how are you going to deal with the safety cases with human loading? How are they going to be trained to do this, having specialist personnel to look after it, and accountability? Do we blame the person who loaded it for when it fails? And then volume, how can you do this at scale when you have so many humans involved? Automated loading, this is an example of Matternet. It's still not widespread, but Matternet showing their little pod here. This goes into there, and on a little belt, it goes up into the drone. Amazon, I found, was the most advanced. They have conveyors in the warehouse, which bring the product to the drone, and then the drone is taken on rail tracks to the takeoff pad outside. Volocopter, they are showing this very, very heavy lift drone here, but with, as far as I understand it, this is purely a static demo. It's not actually active. Right. Drone garaging. Why do we need drone garaging? Well, what do you do when you want to charge the drone? What do you do when you want to inspect the drone? What do you do when you're not using the drone? You need to put it somewhere. If you look at the cases of Wing's drone delivery service, they're basically leaving them outside, as far as I can see, and they seem, as far as I've seen, to leave them outside for a long time. And again, access is by humans to collect them, to check them, to charge them. And the closest as an overall solution is the drone in a box, but that doesn't map into deliveries. So what I want to start now, because I'm just halfway through this, I should have enough time to finish in 20 minutes. Motion Robotics' work in OSPREH, we looked at parcel handling and automated drone garaging as, so that parcel handling includes parcel loading, parcel unloading, parcel lockering, automated drone garaging. And so hopefully now, if everything works, we can see some of the results of the project. So if I click, so what you're seeing is our parcel loading, unloading, lockering rover. It is omnidirectional in its capabilities. And on top of it is a VersaPack medium size used very much by the NHS, pretty much standard equipment as far as, for example, deliveries between Portsmouth and Isle of Wight. The drone is Titan, our hexcopter, which we use. And as you can see here, the parcel rover is now activating the lift and bringing the parcel towards the grippers, which are underneath the Titan drone. And the idea here, the grippers are such that they can accept a certain amount of error between the positioning of the rover and the drone, but obviously we try to minimize that. and the idea is to effectively fully autonomous. This is actually fully autonomous, no manual in it. This is an example of drone unloading. So the drone is landed, we come up to it, and so that we don't drop the parcel from height, the lift on the rover climbs up, the grippers release, and let's see, and I could speed up a bit for sake of time. There. And here we see, assume that now he's at the locker. He pushes it onto a shelf in the locker space. Well, not as badly as this, but effectively onto a shelf, and then goes off to do other things. So okay, so this is a demonstration of the automated drone collection for garaging and recharge. So again, you see the Titan drone, and we have what is called our garaging rover. We're designing these rovers to be drone agnostic as far as possible, within the limitations that one has between different manufacturers. But what we try to do is ensure that the coupling mechanisms are as tailorable as possible. So here again, it is a bit slow. It is a prototype, so it's a bit shaky. So I'm not gonna. And but essentially, what you have is positioning of the rover is done through these so-called April tag visual markers, and using cameras above the platform. We assume here, for example, he's entered into his garage, and we get him dropping him off. Just get my phone to check on time because I can't see time. Okay, so here we see him dropping that off. And he goes away. So I'll just spin through that. Here's another example. There you go. So parcel drop-off. This is what we're trying to show here is a situation where you're not loading it manually, but as automatically. But since you already saw that we were loading it automatically, you can assume that this is a parcel going to somewhere where there is no infrastructure. So this is just mainly to show what we call the wedge, which is the device that holds on to the parcel, and also to demonstrate our pinpoint landing accuracy. So this has been carried out at a farm close to our offices. And pretty much we get within 10 centimeters every time. And here you can see the drop off of the parcel. And then obviously the drone would take off and essentially, let me get my mouse back, fly back home. If I speed that up, we can see again here, very accurate landing and drop off. Okay. I talked about the winch. What we have on our systems is a combination of the winch and the wedge mechanisms. The wedge mechanisms ensure that the parcel is not going to be rocking around and vibrated and pendulous, but up here is included our winch mechanism. So have a look at this. This is in the lab. And as you can see, there is an automatic release of the mechanism that holds onto the parcel as soon as gravity, as soon as the parcel effectively there's no more gravitational force. It will release the parcel. This is a typical test where we have to do multiple tests to prove the principle. And finally, this video here is to show you an early animation of how typically this would operate in practice. This was the vision between the OSPREH project, where there would be a structure, there would be drones and rovers and parcels, and drones would fly in and would be automatically loaded, and the rovers would return, and the drones would take off, and obviously in reverse, and obviously including drone garaging, where the drones would end up being garaged in these corridors. So in conclusion, what we've done is showed you our progress in the project towards automation of cargo handling, primarily looking at removal of human in the loop for cost safety reasons, and achieving this by leveraging AI and machine learning techniques at the level of embedded systems. The project also carried out a bunch of other AI stuff, which probably we can talk about at another session. So that's the conclusion. Any questions? And thank you.
Dennis, that was absolutely fantastic.
I think you're muted, Paul.
Hello.
Thank you. I'm hopeless today. I do apologise. Thank you very much, Dennis. That was absolutely fantastic. Sorry about being muted there. Annalise, you've got a fantastic question in the chat. Do you want to ask it? And now Annalise is doing the same thing as me. You're muted, Annalise.
I know, and I mean, you would have thought that we would have sorted this one out by now, but not yet. So thanks, Dennis. It was extremely interesting, and I have a question with regards to how, if you had the opportunity to discuss your approach with the medical teams or the quality managers in terms of how it compares versus the current status of probably manual handling in road transport. And I was thinking, how do they react in terms of chain of custody, maybe, or contamination risk? Basically, what's the point of view from a purely medical standpoint, not a CAA standpoint, their own standpoint?
Okay, good question. We've had several meetings with NHS Trust Management, where they all favor an automated process because the porters only, their work role only covers a certain amount, and they don't want to have specific staff, extra staff to do the loading and unloading for safety, health and safety, also for the training aspects. And so from their point of view, at the level of personnel, they're looking for automation. That's one strong feedback we had. Contamination and custody. What we essentially are looking at together with the University of Southampton is this question of contamination. To a large extent, it is covered by the packaging itself. So the VersaPacks are security bonded. I'm not sure the expression to use.
Tamper-proof. They're tamper-proof.
Yeah, they're tamper-proof. Plus, they are RFID tracked, as well as something like QR code tracked. So we know where they are at any point along the logistic chain. And as far as that's concerned, we have less input and direct action, but I agree that is already being discussed and treated in one or two other projects in which we're involved. Not only that, but issues such as vibration, pressure, temperature, all these sort of concerns that MHRA would probably be worried about.
Great.
Muted.
Oh, I've managed to switch myself off. Oh, there's Olivier's got his hand up. Do you want to unmute and ask your question? Here he is.
Hi everyone. Yes, I just wanted to point out that actually Martinet is doing a lot of operation research around the maintaining the chain of custody when transporting medical cargo. They are partnering right now with a hospital. I believe it's in Germany. Yeah, it is in. Yeah, I think it's in Germany, where they're exactly looking at how can we make sure that best practices are maintained when transporting medical cargo, because we should always treat any sample as it's a biohazard. Always treat them as being infected, so they have to follow best practices. So that's something, if you're interested in that, and Liz, maybe they have a great input, a great experience to share with you guys.
Excellent, thank you. I've got one very simple question. Of course, I come from the medical background, so of course I'm going to ask a CAA type of question. It's quite interesting that. I'm just very scared by winches. If a wire or a rope is coming down, I can pull it. So what's the CAA's opinion of winches and cables coming down to the ground level?
I'm not sure what their opinion is, but I know that several drone operators raised that question. So the parcel can get hooked on something. Someone could deliberately pull on it, and essentially there are two possibilities. Well, we cover both possibilities, but we prefer one. You can either cut the line as soon as you detect something strange, or you can roll out the winch to its end and drop the string, drop the line. The most important thing is that the drone mustn't be dragged to the ground. If the string falls down to the ground, that's probably not such a big problem. But definitely, a lot of the winches that we've researched don't have any sorts of functions of this type, because obviously, well, not obviously, but it's like detect and avoid. It's you can detect something, but the question is, how do you avoid it? So here you can detect that you are being strangely pulled down and high forces on your lead, but what do you do about it? So in our case, as I say, we cut the line or we roll out the line.
Thank you. That's okay. That's reassuring. Good, Dennis. That was fantastic. But we've got a packed program now, so I'm going to ask if that's okay. David, are you ready to go? Oh, David, you're muted now.
That's just my little joke there. I was.
Oh, yeah, you were mouthing away.
I'll just share my screen. Hang on a second.
I do like field work where the person organising it is holding a megaphone. That is absolutely tremendous. That's.
Thanks very much. I trust you can hear me and you can see the slides.
Yep, loud and clear. Brilliant. The floor's yours. I'm going to disappear now.
Thank you. So, just out of an introduction of this great photo, I think it's a great photo. That's a box with a drone in it that was delivered to an island by boat in Lake Victoria. I love the photo because, you know, there's the old technology of how we're trying to deliver things, and these gentlemen carrying the box are walking through your hearts here, delivering or getting help from people who are high risk with AIDS and malaria and other issues. So thanks, Dr. Paul and attendees, for taking the time to join us. I'm honoured to join such a knowledgeable group with great presenters. Thanks, Dennis. Looking forward to Veronica's next. I just want to go through a range of experiences. Hopefully they'll add to your knowledge base, how you might include drones in healthcare assets, medicine, medical access planning. My focus is on humanitarian efforts, low to middle income countries, really. But I've found a lot of exchanges useful, you know, with the UK, for example, and vice versa for developing countries with those that are more sophisticated. These are my views, by the way. They're not the views of the World Bank or African Drone Forum or anything like that. So just quickly about me, I've had 40 years in aviation, air traffic control in Australia and Europe, research and development for 35 years, including time with German Aerospace Centre. For the last decade, I've been involved in drones, mostly as a volunteer. The African Drone Forum and a whole lot of standards groups associated with the drone ecosystem. I also represent a group of air traffic controllers on international bodies as well. I consult for the World Bank on all things associated with drones. So I'm going to cover the details of healthcare through the lens of the drone user. We'll look briefly at cargo drone operations in Africa, and I know you've had a lot of those covered already. The related ecosystems, the relationship between risk, accepting risk, understanding the benefits associated with risk and the trade-offs there, along with some environmental issues and other risk topics. So just basically, I guess I look at Band-Aids and blood delivery, not burritos and billionaire type stuff. Just so we know what we're talking about, I'm focusing on uncrewed aircraft systems, so drones, smaller platforms, often called UAS or unmanned aircraft, operating in the lower skies. We're not talking about larger, certified cargo, remotely pilot operated systems. So the aircraft we're talking about are generally not part of the air traffic system. They often don't receive an air traffic service. And then the drones themselves, you know, Dennis was sort of showing us some really interesting information there. Drones are either vertical takeoff and landing. They can be hand launched. They can operate from a catapult and land with a capture cable, a catapult. The hybrid platforms, they take off like a quadcopter, then they get lift on forward flight. Electric, they have a lot larger, a lot longer range. And they reduce the need for extensive infrastructure. And when you get into the heavier platforms, the risk becomes higher, the opportunity for harm to those on the ground, conflict with other airspace users, etc. So, by the way, some of these platforms have recovery systems, parachutes on board, and that's a pretty interesting thing to consider if you're getting into this game. You know, you really want to consider the risk, and I'll touch on that. These are the sort of drones that we're not talking about. If they do happen to crash, out of control and crash, they cause a lot more harm. They generally have a lot longer range, so they can impact airspace for a longer time. And there are trade-offs, of course. It's nice to have a larger payload. Sometimes, though, and we have some experts here, and I really call out Olivier from Village Reach on his knowledge, but sometimes you don't need to move much around. So smaller packaging can be quite invaluable, in fact. There's also the point where Dennis was talking about if you winch down or if you land and take off. If you land and take off, you need to train the medical staff on how to be safe, how to load and unload the cargo on a drone. So that's a really interesting point. Why drones? Well, I love this photo. I mean, I hate this photo as well, but this is what it's like, as you probably well know, in the global south. Only 34% of Africans live within 2 kilometres of all-weather roads. It's 90% in East Asia. It's a lot better across most of Western Europe. It costs a lot to commute between these places, to deliver. When the monsoons arrive, the roads are a mess. And that's when drones are least effective because sometimes they're not efficient in bad weather. There's a lot of critical supply chains that fail. The rural dispensaries run out of stock. The stock goes out of date. And then blood tests, for example, the classic example, they spoil in transit. And then also there's the road safety factor. Africa is the third of all the deaths in Africa. It's HIV, then malaria. The third is road deaths. So 20% of the road fatalities worldwide, only 2% of the world's vehicles. Other factors, you might want to try and deliver snake venom. 1 million snake bites a year in sub-Saharan Africa, around 30,000 deaths from that. And then repairing these roads is prohibitively expensive. So innovative solutions are good. African Union realises this, the Executive Council in the Education, Science and Technical sessions adopted, I think 4 years ago, adopted an approach to prioritise 3 key emerging technologies, one of those being drones. So my approach to safety risk management is really one of reflecting on the world's best practice and improving it for Africa. And I've had this confirmed many times. I've had people come to me at industry events in the UK saying, where's the best place they can take their drones where there are no rules that are going to impede their growth? I find that kind of offensive, but this is how the game goes sometimes. So what I've done is I've made sure that the bar is as high as possible when it comes to risk management for any of the drone events we have. There are a lot of operations of drones in Africa. Previously on DRACHMA, on Dr. Pool's efforts, you've heard Dr. Roslin, the Johnson & Johnson trial, I think, sponsored it, but discussing efforts on any retroviral, maybe, therapy, medical samples over to islands in Uganda. Gabo from Village Reach, the drone costs, cost effectiveness analysis, along with other projects. There's DRC trials, I think we've had mentioned. There's trials in India and other locations. I just want to take some highlights from those. Madagascar, over 700 successful flights, actually probably more, and they have a Made in Africa drone that they're operating there. It's got a great range. It delivers a small but essential package, and it's got a parachute on board. Malawi is a leader in drone delivery efforts. 2 companies provide regular service through UNICEF, outside of the UNICEF and Malawi government drone corridor, across large regions. But there are a lot of complexities with having various drone operators and lots of operations. Zipline, I think we all heard of Zipline. They're operating in Rwanda, Ghana, Japan. Agreements come up in Nigeria, Cote d'Ivoire, Kenya, India, Philippines, Japan. So they do blood, whole blood, platelets, plasma, and some of the figures are quite amazing. You know, the number of blood deliveries that rely now on Zipline are really high, and they're delivering COVID vaccines, as are other companies, but it's a quick drone, it's light, it doesn't have wheels on board. It's an incredibly robust system from what I've seen, the flight management system and the automation. You know, one pilot can have 30 odd drones flying, and this reduces stock out significantly. I just quickly compare Europe with Africa, and I do this because there's a similar number of countries, a similar size, you know, populations aren't dissimilar. Africa, it's 55 member states. And yet the regulations, the regulatory framework in Africa for small UAS for 150 kilos and below is common. It's common across all European member states. We were part of that in the UK until Brexit. We still have some alignment, but that will change. So interesting, if we can do that in Europe, why can't we do the same in Africa? Language barriers are common across Europe and Africa. I mean, a third of Africa is Francophone, a third Anglophone, 5 or 6 Portuguese, etc. So these are barriers that we've overcome in Europe, and there will be massive advantages to this, and these advantages will flow down into medical delivery and supplies. So the World Bank and the African Drone Forum, we've identified the gaps where we could put in effort to support the drone ecosystem. There are 7 documents, knowledge pieces. Most of them haven't been published yet. They're held up in the publications mill at the moment, but they will come out shortly. A really important one is this number 1, the playbook for enabling civilian drone operations. That'll come out shortly. That's going to be really, really valuable for everyone involved in industry. When it comes out, grab it, have a look through it. Across the country with regulations and harmonisation, there is little harmonisation. Regulations are changing. Half of member states don't have anything at all, as in no regulations, rules or guidance. Some have regulations, about a quarter. Some have information on their web pages, on their landing pages for drone use. That's about 10%. A quarter say they're currently drafting new regulations or revising their present rules, but the majority of those are dissimilar. So you can just see that comparison with Europe, standardized, harmonized, interoperable across other regions, but yet Africa doesn't have this opportunity. You may not know about the African Drone and Data Academy, supported by UNICEF mostly and Virginia Tech, the Malawi government provides a lot of education, not just in flying drones, but using the data. Now, data is not a piece you're going to be that interested in from the medical community, but there can be crossover technology where a medical drone can pick up data on its way through. What we've done, back in 2018, I was operations manager and safety lead for our first ever big event in Africa, the Lake Victoria Challenge. We're really a proof of concept to see how drone technology worked in East Africa. We had a range of flights, and our idea was to do a find and assess piece, but for our listeners here, a delivery of products over to an island, a very small island, Juma Island, 20 kilometres off the mainland. So it was essentially a trial. It was very successful, a lot of interest. But then 2 years later, we moved to Rwanda. We had the African Drone Forum, 1,000 attendees, 50 countries, 100 speakers, breakout tracks. And we really started to frame how the supply chain becomes an essential part of drone land. We had traffic management showcases, drone business challenges, and a VIP's day with many flights so that everyone could see what was going on. Plus, we ran this Lake Kivu challenge, a lot of it sponsored by the Department for National Development of the UK, just out of interest. This was in Western Rwanda, over a lake, because I haven't been able to cope with ground risk of flying over large populations yet. We had, I think, 1,000 kilometres, maybe 100 beyond visual line of sight flights. And the focus was on emergency delivery. Well, that's one piece. Pickup can be emergency pickup as well. That's the second piece. And if you do them together, that's bi-directional. The find and assess piece, again, perhaps out of your interest here. We had competitors from 14 countries in Africa and beyond. Let's go back to Lake Victoria, second largest lake. It covers 3 countries: Kenya to the northeast, Uganda to the northwest, and Tanzania in the south. If we have a look in the southern section there, we were flying out of Mwanza in 2018 on the shores, and we were delivering to Juma Island. I mentioned that little insert to the bottom right. That shows the 300 medical supplies facilities and depots. Mostly difficult to reach, some are very hard to reach. And so we were trying to replicate how that would work. But you can just see how many locations there are that people struggle to get medicines to. The people working there are unable to get supplies. This is a concept that I came up with a while ago. We could use a range of drones, hub and spoke, around the lake. There's over 3,000 islets on the lake. I don't know how many are populated, but many have health facilities, and stockouts are, again, a major issue. Malaria, HIV, AIDS, bilharzia, etc., etc., etc. People have a terrible time here. There's 57 drone ports on this particular map, and you can service them with one larger drone doing a range of drops in one day, or a whole lot of smaller drones having multiple flights. I've got 7 minutes left. I really want to touch on the safety risk management piece. This is my expertise and what I hope I bring to most of the operations that we support globally. On the left-hand side, that photo, that's an airborne shot of the health depot on Juma Island, and that's the landing ground. Kids everywhere, of course. It's a footy oval as well. So risk is an issue. How do you land there? So we focused on drone ports on the coast to reduce the risk of overflying people. We had to consider the weather. The weather forecasts are either non-existent or they're inaccurate, especially for the low flights or low altitude flights. These are different risks from what you'd experience in the medical fields, but I'm sure you get the idea. Aviation risk, it hasn't changed over the decades. Well, it's improved certainly, but now we have to consider ground risk as well. With people on board the plane, we don't consider ground risk because we're already automatically saving people's lives on board the plane. But now with no one on board the drone, we have to bring in this extra consideration. And if you start considering ground risk, you then need to rely on the data quality of your mapping, of your population densities and censuses. So the World Settlement Footprint, for example, of 2019 is the most accurate data we have, and it's still out of date. You can't really fly safely over large communities in case you do crash. There's also issues of connectivity and surveillance quality. So the air traffic controllers won't have any surveillance in a lot of these countries. What happened 5-6 years ago within the safety world for drones was an operational categorization. And at the bottom of this, there's just standard airspace for most of this slide, but at the bottom of it, you can see the very low level flights beyond visual line of sight, away from the vision of the pilots. It needs connectivity. It needs an understanding of who else is there in the airspace, obstacles, etc. And if a flight is visual line of sight, then we know it's lower risk, and that's called the open category, or category A. This is adopted across Europe and many other member states, this categorization. If you want to fly further than the pilot, which of course we do, because you want to deliver and pick up medical samples and products, so we need to fly beyond visual line of sight, and that takes us into a specific categorization, and this has changed our risk approach immensely. We can now use conventional safety methodologies, but adopted to this new entry into the risk field, that's drones. And this has come from the Joint Authorities on Rulemaking for UAS Systems, of which I've been a member for many years. And they have a complex thing called the Specific Operations Risk Assessment. It's actually a methodology, and all it does is transfers information from the operator to anyone else who's interested. For example, security or the Civil Aviation Authority. It's a flowchart model, 10 steps, 10 annexes. We haven't finalised them. It's known to be very, very complex. Unfortunately, it's not designed for Africa. So I'm working with other groups to come up with something that suits the global south. In UK, the talk of the town for drone operations is temporary danger areas, how to assimilate, segregate, separate, accommodate, whatever we want to look at, drones into the present aviation system. With our airspace users, it's a very complex place. 0.003% of African airspace or land space has controlled airspace. There's an enormous amount of areas in Africa and other developing countries where you can fly drones and there's nothing else out in the airspace. So, you know, all of a sudden we have opportunities. This slide shows the restricted area we created on the border with Congo to the left there, and on the right-hand side is Rwanda for our flying operations. To the north is one of the United Nations' busiest airports, Goma and Gisenyi in a nearby airport. So we operated inside segregated airspace. It removed all of the risk. We still had to plan for violations. You know, a conventionally piloted aircraft could enter the airspace, or one of our medical drones could have exited it. But that was a much better way to look at it. From the ground risk point of view, again, we have to be very strict. JARIS provides us with guidance. We're working on it to adopt it to Africa with safety risk probes. Now, this is the drone port in Karongi on Lake Kivu, and we had to push the drones down low. We had to slow them down as they transitioned to a landing. We had to make sure that we control the airspace around these operations so that we didn't have any fatalities or harm to people in a crash. The top right photo, that's a World Food Programme effort delivering cargo into northern Mozambique. I think it's the Cabo Delgado area. And so that's a town that's not on the map. And there are towns that are marked on the map and not there. There are towns on the map that are not on the map, sorry, in situ, but not on the map. So data quality is a real problem. Operational safety, you need to track drones quite often. The center top picture is one of our friends from Switzerland putting a receiver, tracking device to track drones on a rock in the middle of the lake because there's no infrastructure. The picture below it with the red lines, we used the mobile cell network in Rwanda to track all of our drones, so it was a lot easier. But there are issues with infrastructure, with electricity supply, with having the right SIM cards, for example. And then there are these other problems, birds, wildlife, really essential stuff. Oh, hang on, that's probably my reminder that I have to stop soon. The center top photo is lake flies, and they'll bring a drone down. You can't see them. And then we were about to fly on the top right when this water spout came up. So these things are very difficult to assess. When the flight operations become more complex or higher risk or carry more dangerous goods or operate near people, et cetera, you need some sort of traffic management service provision. These are expensive, complex, they're still being designed. So there are a lot of future operations that we can consider. Cross-border and international flights are different. Cross-border means one company can operate in various different countries or localities, whereas international flights means you could take off from Tanzania, overflow Uganda and land to the north, or you could make a delivery. And Olivia's with us on this call and we try this from the Congo Rwanda, for example. These bring up a whole lot of different regulations, international regulations that we have to consider. Just in closing, I want to quickly talk about drone operations flying manuals. The manual is where you take all that information I showed you before in the specific operations risk assessment. You look at drone importation problems, frequency spectrum, if you have any cameras on board, how do you manage the data and the privacy of those you overfly? And on the bottom left, we start looking at the air risk and the ground risk, and I'll expand that. The concept of operations describes the operation that you want to fly, that you intend to fly, and then you do a full risk assessment. It includes safety, I mentioned that before, air and ground risk, but also security. You don't want to be hacked. Occupational health and safety for your staff. Geophysical risk, flying cross-border, flying near borders, and then environmental hazards. There are a large number of factors here. One of the most important is outreach to communities. In a lot of these places, people have never seen a drone. They don't know what a drone is going to do, and they could feel that they're at risk of losing their job. So thank you very much for listening to this, and I don't know if you want to do questions now or later on.
David, that was absolutely tremendous. So we've kept a high level from Dennis's to yours. That was brilliant. I've got a couple of questions now. So what have I got here? I've got a question from Andy. Do you want to unmute yourself, Andy? And it's about uniformity across airspace regulations, I think. Andy, are you there? Here he is.
Yep, I am. Hi, David. Really good presentation. Nice to see you again after last week. My question was also with the airspace. So around the fact that the lack of uniformity, is that not potentially giving a bit of an opportunity as well as a sort of challenge? Because if you're flying within the same country, surely you're having to comply with fewer sort of uniform standards.
And are you referring to flying within the UK or flying in many of the places?
In Africa, where there were lots of different, it was sort of a patchwork of different standards.
That's a great question. And I think possibly a lot of it comes down to the capacity and skill set of the Civil Aviation Authority. Many Civil Aviation Authority employees don't really understand drones. It's not part of their day-to-day job. It's also not a revenue earner in countries. So if one particular inspector thinks that it's fine, they may not understand some of the intricacies of it. They might allow it in one country, and exactly the same operation may not occur in another country. So capacity building is an essential piece. I think your question is really framed around, if I get it right, the opportunities that this gives. Certainly, if there are no other aircraft in the airspace, then it does open up to a lot of opportunities. But an example in Rwanda, for zipline, they've struggled to allow flights within controlled airspace. So the size of the controlled airspace, the control zone protecting Kigali Airport, was reduced from, I think, 30-mile radius to 15 miles radius, just so that they didn't have to allow zipline into their controlled airspace. The zipline still had access to a lot of the routes. Does that come close to your question, Andy?
Yeah, no, that's really good. Thank you.
Cool. Annalise, you've got another cracking question. Do you want to unmute?
Yes, hi, David. I have a question in terms of the attitudes of the different authorities in Africa versus safety risk and maybe also social perception. Do you have a point of view in terms of how they perceive it versus maybe, let's say, the UK?
Hi, Annalise, good to see you again. Yeah, that's a great question too. I know that the UK is prominent in most of the forum that I'm on. Some of the African civil aviation authorities and other authorities are involved at a level. But I got to say, it's a pretty complex piece, and I'm sure you're aware of that. This flying drones around beyond visual line of sight with stuff on board that perhaps is dangerous is a really complex piece. And many regulators don't understand that. I mentioned that before. So they'll fall back on what the regulations allow them to do, not areas where they could give exemptions or accept alternative means of compliance. Until there's a standardized methodology that for safety that can be rolled out across the global south, there's 100 or 110 countries, then I think we're going to have this issue where one country says yes, one country says no, and the regulators have different opinions all around the place. I think you mentioned social perception as well. I don't know how to answer that, Joanna. That's a pretty good question. I don't know if Olivia, do you want to chime in on that one?
Well, in terms of safety, there is the factual analysis of risk, and then there is also a political flavor to it. And it ties with social perception of how good it is for your, your citizens, I guess.
Yeah, I get your point. And I purposely didn't mention risk benefit in this presentation because there is acceptance of risk, and then there is this comparison of the benefit of an operation, the medical benefit, for example, with the risk. And we try this in NATO. I was on a scientific group in NATO years ago, and it's a really hard one to address. You could say, oh, well, I'm going to save 5 people's lives if I deliver this product, but I will risk 20 people on the ground if I fly over them. So it's a terrific question.
It's really hard. I threw in a couple of questions, but Olivier nicely wanted to sort of chime in and answer them. So Olivier, do you want to sort of unmic yourself, because I think you've got some nice opinions about that. I think one of my questions was about airworthiness, something about the urban sort of operations in Africa, and I also followed it up. I think there was another question that bidirectional, because some of the user cases that have been dropping out are healthcare, yes, but if you can get another type of cargo on board, you could the cost benefits could actually improve a little bit. So Olivier, you nicely offered some answers to some of my questions.
Yeah, and I don't want to be pretentious. This is just elements of response, and it's a personal opinion. But you're very right that the studies, the research have shown that if you only limit your value proposition to cost effectiveness of using drone, it's not going to be the case for quite some time, 5+ years, most likely. But one way to approach is by layering the use cases. And when you think about the level of investment, and I'm not saying just financial, operational, of integrating or introducing a drone delivery solution, it's a system level change, very complex, that involves software, hardware, that involve human resources and regulations and multi-sectorial. It's the level of investment is so huge that you have to think across application. And the bi-directional for me is a no-brainer. Any logistic expert will tell you, if you invest so much into a solution to go one way, why it's coming back, it's like coming back empty, right? So the bi-directional, while introducing a challenge, an additional challenge, if you land or do not land, it still adds some complexity, I think is definitely worthwhile. And I think I love the first presentation that we had, and there's a lot of research being done around safety of loading, unloading, and so on. But the bidirectional is also a priority for a lot of governments. In the health sector, if you look at national supply chain strategy, the reverse logistics is a big priority in many of African countries where we work, and I'm going to be a little more specific on Africa. We see, the pandemic, the needs to strengthen the surveillance, safety, and disease surveillance programs is huge, which is linked to diagnostic, which means that you need to bring back sample back up to where they can be tested, and so on and so on. So it's also an alignment with government priorities. This bidirectional options is really an element that is aligned with also government priorities. One way that we are, Village Reach is dedicated to do in the next few years, and we actually developed a 3 years plan, is to how can we sustain those operations by leveraging the commercial application of using drones. You know, the entry point for the last 7+ years has been healthcare, right? But the drone is agnostics. The cargo that is carrying is agnostic to what you put into cargo if it fits. And so we're preparing a 3-year study to deploy a drone delivery solution into the private sector, leveraging private sector companies, logistics, who will be absorbing that additional mode of transportation into their offering solution, trying to leverage the existing customers to start generating some revenue in order to then subsidize for less revenue generated application, which include the public health. And so it's really around, we have to break the silo between health and others. Drone is just an additional mode of transportation, agnostic to the sector. We must start looking more broadly, agnostically to the sector. And it's only also by looking across sector as well as a large scale that the cost effectiveness and the number will start making sense. There is many theoretical study. Now we have to prove it by generating hard evidence and hard data, which is what we are preparing to do with a lot of different partners from the private sector and traditional donors, because that data is still missing.
Fantastic, Olivia. That absolutely. I mean, I think at the start of your presentation, David, you mentioned something about data, about the importance in some sectors, but not others. Just in the safety case, everybody in a hospital in the UK will want to have a look at your data to show that that aircraft has flown 1,000 times, 10,000 times before they even sit down to look at other parts of the piece as well. The estates manager in a local hospital, that's the first thing they want to have a look at. So it's really important. I've just got an eye on the clock, so I want to bring Veronica in. And there's lots of preconceptions and unconscious bias. And one of the things that made me chuckle is there is an argument, a user case around snakes in Norfolk, where I live, because people are allergic to the venom, the very tiny ones. And we've got no dual carriageways, and so when it's holiday time, you can't get down the roads to get the venom to your person that's having an anaphylactic shock. So there are similar types of issues around the world. I've got a hand up, Veronica. You've grabbed the screen, which is absolutely fantastic. So thank you very much, David. And just to finish up, I think Demetrius had a fantastic question, but very kindly Nicholas provided an answer in the chat. So that circle's been closed, which is good. So Veronica, the floor is yours.
Thank you, Paul. Good afternoon, everyone.
Oh, you're just a little bit quiet. Could you increase the volume of your microphone? Sorry to be a pain.
No, that's fine.
Or it could be me. It could be nearly 2 years of having a thing in my ear.
Can you hear me now?
Yeah, yep, that's good.
Okay, thank you.
Are you okay sharing your screen? Oh, you are. Fantastic. Yep, we can see that. That's brilliant. Oh, you've gone on mute, Veronica. Sorry.
We'll get there on this. I think, like the lady said previously, we should have this perfected by now, shouldn't we, after 2 years? But
we've been doing this for 2.5 years. It's nuts.
2.5 years. But yeah, good afternoon, everyone. And thank you, Paula, for inviting me to present today. So I'm going to give a brief sort of overview of our incubation and scale-up facilities and tell you how a bit more about how we're supporting drone technology innovators. My name is Veronica Rigby. I work within our research and innovation office, and I lead on business incubation support for Cranfield University. So Cranfield University, we're a designated university enterprise zone, and we were awarded 1.2 million by Research England to support the growth of an aerospace and AVIATE business cluster. And this funding has enabled the development of a new facility called AVIATE, and this will operate alongside our Cranfield Eagle Lab. Cranfield Eagle Lab is an initiative that was developed in partnership with Barclays, and it's a successful business incubator facility at the Cranfield campus for early stage companies in the aerospace and AvTech sector. And the new AVIATE facility will provide grow on scale up space and tailored business support for high growth companies as they move forward on their growth journey. So this is a picture outside of our Cranfield Eagle Lab. As I mentioned, it's on campus, adjacent to the university. It has a dedicated management team from Barclays, fully equipped makerspace, lab engineer, co-working desks, private offices, and access to university expertise and facilities. It's also supported by Codebase and the wider Eagle Lab network alongside the Cranfield ecosystem. We also have a Royal Society entrepreneur in residence at the lab. Now, AVIATE Plus is directly beside the Eagle Lab, so adjacent. It's in the building right beside the Cranfield Eagle Lab, and this facility has private workshops which will enable larger scale prototyping. It's got a fully equipped shared makerspace with on-site engineer, co-working desks, and tailored support to assist companies to scale and succeed. We launched virtually last year and were supported by Paul Scully, Minister for Small Business. We were due to open towards the end of the year, but due to the dreaded COVID, which impacted on some of the building aspects, we're opening this month. So just a few photos. Now on our main website, there is a recording of that event with a virtual tour, and you will be able to actually look at the virtual tour on that site if you want to have a look around. But this is just to just give you a sort of glimpse from outside. We have the ground floor of this building for a co-working space, and the picture on the right, the funding enabled the development of this extension, which houses 7 private workshops and their maker spaces. So just so you can see inside, on the left, this is our co-working space. Still needs some few sort of cosmetic bits and pieces doing to it, but we have private meeting rooms, shared kitchen facilities, and behind these chairs, this window gives you a glimpse into the maker space. Again, so on the right, that's the that's the fully equipped maker space. The Eagle Lab also has a maker space, and members of either facility can work between both those spaces. So the Eagle Lab tends to have houses sort of small equipment, 3D printers, and the sort of larger equipment is here in the new extension. So there's cutting equipment, mills, saws, but as I say, residents can move between the facilities. Here on the left is inside one of the private workshops. Now, before anyone asks me what the dimensions are, I would need to double check, but someone I think described it quite clearly in terms of the size of a small car you could fit in there. So what we're looking at is we've already had a couple of drone companies that are looking at housing some of their sort of larger sort of prototypes in that space. And in terms of location, we're fortunate to be located right at the heart of Cranfield's Global Research Airport, which gives our residents access to facilities, easy access to the experts within the university. So it's a fantastic location, and we're right beside the airfield. Okay, in terms of just a bit of a glimpse on some updates around testing capabilities, some developments in the pipeline at Cranfield Airport is that we will be able to accommodate routine BVLOS UAV flights inside the aerodrome traffic zone for suitably qualified UAS operators. And this will be a great enabler for UAV companies that are developing longer range UAV based services and solutions and or ground-based system testing. Cranfield Airport will also be able to provide a low-level UAV zone at a safe location at the end of the airfield for the purpose of operational training and sensor testing. And these are some developments that are imminent, but it's just to give you a bit of a flavour of what's happening. So why Cranfield? In terms of attracting small businesses, I think we have quite a unique combination in terms of technical expertise, access to Cranfield's world-class academic research, business support. We have our Bettany Centre for Entrepreneurship, who can support companies on their business side of needs. We can tap into our Barclays Eagle Lab nationwide ecosystem, and we also have 2 Royal Society entrepreneurs in residence. We have the world-class facilities, obviously Cranfield's Global Research Airport, which includes the new so recently opened last year Digital Aviation Research and Technology Centre, DARTEC. And then we're a university, specialising in postgraduate education. So we have that fantastic resource of having highly skilled graduates who we can introduce to companies to work on projects, internships, KTBs and PhD opportunities. And just highlighting some of the key benefits for businesses and innovators. We have a variety of membership options. So across the 2 facilities, we aim to be able to accommodate you wherever you are in your business journey and in terms of your requirements. Alongside, like I say, we're co-located with the university, which gives fantastic advantages, but we're also engaged with the local, national and international business community. We have a fantastic strategic partner network, and companies can really benefit from that beyond the actual physical facilities. So just to highlight a couple of successes in the sort of drone innovation area. One of our homegrown successes is a spin out called Hirotech. They deliver connected drone in a box technology to support round the clock automated drone operations. They cover sectors which include emergency services, utilities, transportation, security and defence. We've also attracting new businesses into the area. We have a company called Surveyor, who's just located in the Eagle Lab. An overseas company called Nordic, these are just some examples, Nordic Unmanned, who have opened a UK office. And we have a successful alumni, which includes a company called Flarebright, who have grown fantastically to outgrow the facilities, and they actually have their own office spaces now, and have a team, I believe, of now nearly 20 people. So we do have some other sort of opportunities in the pipeline, sort of beyond the actual physical support. AVIATE is supporting a multi-stakeholder partnership initiative called the Drone Innovation Hub. Cranfield's the lead partner, and we've partnered with 2 business partners in this initiative to provide almost a one-stop shop. I don't really like that terminology, but that's the best way I can describe it in terms of supporting SMEs to accelerate drone innovation. So between these partners, we look at supporting companies to give sort of quite a holistic service to accelerate business innovation. We also are a supporting partner of the Connected Places Catapult Future of Air Mobility Accelerator, and we work closely supporting their business cohort. We work with the ATI Boeing Accelerator, and our sort of bigger vision for this is to develop this SME aerospace AvTech cluster beyond even physical membership, so that we can connect businesses with each other, Cranfield University and our wider stakeholder partners. And I think one of the things that has come out of probably you know, the few pluses that have come out of the recent way we've had to work is this being you know, is connecting more, I think, with international partners, businesses. And one of the requests that we do get is from companies is, you know, is for us to be able to facilitate introductions to other businesses. So it's sort of organically brought up this need, I think, that maybe to have this sort of joined up approach for companies to engage. So I think we believe that with technology developing at pace, including drones and electric powered flight, Cranfield really is an ideal place to accelerate business innovation in aviation. If you would like to contact, I've put a generic contact address, but I will share my own email address. But thank you very much. And any questions?
Fab. Thank you very much, Veronica, because I think it's really important that, you know, we need a place to test some of the things we're developing in our labs and that kind of stuff. So that's really useful. Anthony, you've got a very specific question. Would you like to unmute and?
Yeah, thanks for that, Veronica. I was just curious about you mentioned BVLOS flight trials within the ATZ, and I was just wondering whether that was going to be to the exclusion of manned aircraft or integrated with manned aircraft, please.
Okay, thank you. And I think I'm going to hand to my colleague Demetrios on that one. So is that over to you, Demetrios? Thank you.
Thanks, Veronica. As you can see, that's the airfield just behind us. So I try to promote our assets as much as we can. Yeah, no, very good question. And the answer is completely integrated. So we've already done testing and quite a lot of flights, even routinely with HeroTech 8 for BVLOS in the ATZ in non-segregated mode, right? So we're trying to develop now procedures which allow that to be done routinely, because initially we were doing it with temporary operating instructions, which you can do with air traffic control, no problem. But because that was not temporary anymore, we were doing it routinely. Now we're actually told, well, we can't really fly anymore for a bit until we put it permanent procedures in place. But the question is, we've done it before, and the ultimate goal is to be non-segregated, fully BVLOS and routinely.
Terrific, thank you.
And just if I may, because that was it is a very unique selling point. Basically, I don't know if you've come to Cranfield, but we have a really nice area which is landside, so you don't need to go through security, but then you're kind of adjacent to the actual airside portion of the airfield. And actually what we did there is kind of segregate initially then that zone where drone operators could come, contact ATC and say, yeah, we'll fly in that portion of airspace as long as they want without really affecting air traffic. So that, although initially was segregated VLOS, but that kind of gathered the evidence that we can do that really safely to then transition into BVLOS for longer flights. And this is the kind of step process we've been following also for testing that you may have heard before, what we called NBEC, National Beyond Visual Line of Sight Experimentation Corridor. We love calling things national at Cranfield. So,
yes.
Yeah.
Thank you.
Sorry, David, you had a question as well?
Is that right, Paul?
Yeah, absolutely.
Thanks very much. Yeah, okay. Well, as an airspace specialist, I mean, that fascinates me. You've just had a 747 skipper ask the question. There are no separation minima that air traffic control can apply between conventionally piloted aircraft and uncrewed, remotely piloted or autonomous piloted, unless they are fully IFR as per the the standards of recommended practices, which we're writing right now, that'll be available in 2026. So, I mean, anyone can do the safety work under the guise of the ANSP or the CAA, but I'm fascinated by how that's working. Reach out if you want some comments on it. Thank you.
So that's, yeah. Sorry.
Carry on, Demetrius, sorry.
So that's exactly what we're trying to do, really characterize the safety envelopes of the drones themselves, the sensors themselves, and all the different functions of that ecosystem, right? You're absolutely right. There's nothing defined, and we're working on defining that ourselves and hopefully informing industry. So far, right now, what we're doing is everything is procedural, and taking into account that right now, you know, with as long as they have visual, is on their traffic control to be able to separate things according to their own procedures, right? And then having gathered the evidence that, okay, well, you have areas where you can fly safely. That is a kind of procedural, in a way, segregated if you want, but actually because they're in the same ATZ and they kind of use areas that are used by aircraft, but when that aircraft is not there, we can do like BVLOS in the same kind of ATZ, but it's all very procedural right now. We're working though through this drone innovation hub, as Veronica mentioned, and through different consortia and partnerships to be able to characterize those safety minima. But you're right, they don't exist, and that's the challenge, isn't it?
Thank you.
But that's the beauty of having our own airport, our own air traffic controllers, our own pilots, because we can work as part of a team to actually work together and actually drive the evolution towards this holy grail of routine BVLOS. And because everyone is part of the same team, as opposed to say, oh yeah, no, you do this or you do that, and I'm not responsible of that. So we're evolving quite well. All about collaboration.
Thank you, Demetrius. That was brilliant. I've got, I think, a very short question and a short answer. I think, Patrick, if you want to unmute, or I can ask it for you. Do you want to unmute, Patrick? It's about size of airspace and maximum altitude.
So the ATZ is 2 kilometers from the aerodrome reference point, and well, max altitude again depends where you are in the well, within the 2 kilometers is like is in, I want to say 5,000 surface to 5,000 feet, but I might be completely wrong, right? We need to ask ATC. I should know that by heart. It's definitely 2 kilometers range, but height really, because it's above the airfield, is quite high. I want to say 5,000 feet. I'll stick with that, and I can confirm it. I'll check the AIS right now.
I can see that mouse being touched to get that data. That's brilliant. Thank you for that. And I think this
is a good question. I should know that. By the way, I'm engineer, and we also have a UAS manager that knows that from the top of his head. But yeah, no, thanks for that.
Good. And I'll just draw everybody's attention. Andy's put some nice things in the chat about shared airspace progress and Project Lima, and I'd encourage everybody to have a look at that. And most definitely, don't forget the impact of visually witnessing these things from people in the healthcare sector. If you're happy about doing BVLOS where you've got regular landing and takeoff with other airplanes going on, just some of my colleagues seeing that will lower their blood pressure. It does sound very, very trivial, but as soon as you start talking about drones, as I said earlier, to an estates manager in a hospital, they want everything to stop. They don't want to have anything to do with it. They're worried about car parks and that kind of thing. So that's brilliant. Now we've got a few minutes left, and what I was going to do was going to be slightly cheeky, because as you've probably all picked up, I'm quite creative, but in terms of organising stuff, it's a bit of a challenge sometimes. So I'm just thinking about the next speakers. Now, what have I done here? Have I gone off in? Yeah, here we go. So while Demetrius is looking up for those figures for everybody, I've just flashed up the plan for other presenters. Now, we've got Richard from GE Aviation that wanted to speak about a very specific subject, which I thought was absolutely tremendous, which is about precision landing where GPS is denied. But I'm just kind of thinking to the group, is there anybody that wants to speak about a particular subject, not necessarily about precision landing? We can open it up a little bit. Or if there's anybody within the network that would like me to approach a speaker. Oh, Patrick's come in and come out again, so that's good. So while we're here, so is there anybody that would like to speak about a drone related healthcare related subject? Or is there somebody that you would like to hear from that I could go out and approach and invite them in? And I think while you're thinking about that, I think Demetrius is going to come back with a number about altitude.
Taking more time than I would have hoped. I thought I had that chart on my
what I'll do then is I'll just put it in the please email me if you would like talk to the network, or yeah, let's just put my email address there. Then I think after that, I think we can bring the meeting to a close. I think it's been very successful. I think we've got some very good discussions going on, and I just want to thank all three speakers, Veronica, David, and Dennis, and your good self, Demetrius, as well. That was brilliant. I think we've learned a lot as a group. So thank you. So before we close, any last comments? Any things that you would like to raise? I can see Dennis there. He's got his microphone on, I think, or has he just got? Oh, hi, Dennis.
Yeah, sorry. I'd like to catch up with Veronica offline with regard to the Cranfield stuff. I know a lot of the people you've been talking about, and I've been following them, and interested to see how we could somehow overlap. Thank you.
Yeah, fantastic. I'll be in touch, Dennis.
Brilliant. There we go. We got a sale, which is good. But I'm going to be cheeky here. If anything nice comes out of this meeting, don't feel embarrassed about sending me a little email to say this X happened because of this meeting. Because I've always got to justify my head of department who thinks drones are things that come in Christmas crackers, and I keep reminding him that it's saving a lot of people's lives and the market is going to be huge. But there we go. So on that bombshell, I'm going to say thank you very much to everybody. Thank you to the three speakers. Oh, here we go. So Patrick, how do we publish it? What I'm going to do is, if you give me about half a day, I will then email you a link through the appointment that I've given to you, and you can find it on the RPAS website, and also a little YouTube link as well. Were you part of the invite list on the Outlook on Teams, Patrick? Yep, that's good. So I'll circulate it to everybody. So there we go. Thank you very much. I'm just going to give Demetrius one last opportunity. I feel really bad now. He's desperately trying to get this altitude.
I feel really bad. I should know that, but I'll put it in the chat. The chat should be open in general, so you'll see it there, Patrick.
That would be fantastic. Okay then, enjoy the rest of your afternoon, and thank you very much.
Thank you.
Brilliant speakers, and I'm going to stop the recording. Cheers, guys. Bye-bye.
Cheers.